All right, let's get started on Unit 4, which is the mole, right? It's a short unit review. It's probably very quick to go through. And let's start. So let's start by defining mole. Let's hope the marker is there. All right. So what is the mole, right? The mole is a unit used to express the amount of a chemical or a substance or compound. So we're just going to call this a unit expressing amount of substance, right? 1 mole of something, 3 moles of that, 16.9319 moles of that over there. 1 unit that expresses the amount of something you have. So then what is the molar mass? Molar mass is the mass of 1 mole, right? Mass of 1 mole of a substance. And if you know me in class, I've been drilling this into your brain by now, but what is the molar mass's unit? Is going to be grams per mole. This is a value that's found typically on the periodic table. Last but not least, we have the Avogadro's number. So fancy. Avogadro's number is the number of particles per unit of substance. And the number that's magical for this will be 6.022 times 10 to the 23rd particles. And that's per mole. But you don't have to write that. You can just know that Avogadro's number is that. All right. So how many moles of gold are in 4.76 times 10 to the 24th atoms? Well, let's go ahead and define atoms first, right? The Avogadro's number constant can be expressed in various different ways, which I don't know why they did that, but it is what it is. So particles equals atoms equals formula units equals, what's the last one? Particles, atoms, formula units, and molecules, right? Molecules. And those all mean the same thing, but all you have to know that if you're given atoms, your units will be in atoms. You don't switch it to particles halfway through, or you don't switch it to molecules or formula units. You keep it as what it's given, in this case, atoms. Based on that information, we are asked how many moles of gold are in this. And what we do with stoichiometry and these dimensional analysis questions, we start with what we're given first. In this question, what's given is that number right there. 4.76 times 10 to the 24th atoms. Time sign, draw a line, of course, all over 1. And so we're going to cancel atoms by placing it on the bottom. And right, the magical number for that is this. 6.022 times 10 to the 23rd atoms. And for every 6.022 times 10 to the 23rd atoms, make that look more like a 0, we're going to have 1 mole of gold, because we're talking about gold. So when you plug this into your calculator, all you're going to do is everything on the top gets multiplied. So 4.76 times 10 to the 24th times 1 mole. Click enter and divide by 1. Click enter. Divide by 6.022 times 10 to the 23rd. Click enter. Once you do that, you are going to get, 1 second while I produce an answer, you're going to get 7.9069 blah 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 blah, which we can go ahead and simplify down to 7.91 moles of gold. That is our final answer. Let's draw that square a little better. There we go. All right. Moving on. How many moles are in 4.86 grams of magnesium nitride? Right. This is a question that a lot of people struggle with, of course, but it is what it is. We got this. Always start with what you're given. 4.86 grams of Mg3N2 magnesium nitride, time sign, draw a line all over 1, and we have to use molar mass. So in order to calculate the molar mass of this substance, all we have to do is go in and find our periodic table and grab the molar mass values from it. So everyone pull out your periodic table if you have not already. And you will find magnesium as number 12 on the periodic table. Each magnesium has a molar mass of 24.30. We can find that on the bottommost number of the periodic table. And that number we have 3 of in the formula, Mg3. So 3 times 24.30 plus 2 of nitrogen. Nitrogen is number 7 on your periodic table, and the corresponding number for that is 14.01. Oh, that's not good. 14.01, there we go. That looks better. And if we 3 times 2, 24.30 plus 14.01 times 2, we're going to get 100.92 molar mass, grams per mole. Using that number, we can cancel the number of grams there. So we're going to put 100.92 grams, and that's per 1 mole of magnesium nitride. And once we have that, our grams cancel and we're left with moles, which is exactly what the question is asking for. So if we get 4.86 divided by the number of molar mass, 100.92, we're going to get 0.048 moles of Mg3N2. Horrible 2, there we go. And that is our final answer. That's it for Unit 4, and I'll see you in video for Unit 5. Thanks.